The moment of inertia, or designated as I, of an area is a very useful property in mechanics problems. The moment of inertia about the x and y axis and the function y is equals to the function of x can be found by integration. So this is the area, and this is the centroid of the plane area. And along the x-axis, we have the distance d. And for computation, Ix, or the moment of inertia along x, is equal to the centroid, or I, gx, the centroid of the given area, plus the area times the distance square from the x-axis to the centroid of the plane area. So this is the formula for moment of inertia. Properties of common geometric shapes. These are formulas generated based on the centroid and moment of inertia. For a triangle with a base b, a height h, and the distance a, to find x sub c is equal to a plus b all over 3, while y sub c is equal to h over 3, which means from this axis going to the centroid and the distance y is equivalent to 1/3 of h. So y sub c is equals to 1/3 of h. Or if the axis is above the point of this triangle, the y sub c is equivalent to 2/3 of h. From this point going to this maximum point, the distance is 2/3 of h, and the area of a triangle is always 1/2 of the base times height. And for the moment of inertia, Ix is equal to the base times height cube all over 12, or bh cube all over 12. The centroid of Igx is equal to bh cube all over 36. Next, another geometric shape is a rectangle, and we have the base and the depth, and the centroid is always 1/2 of the base and 1/2 of the depth. So area for a rectangle is always b times d. And for the moment of inertia along x, I sub x is equal to bd cube all over 3. The moment of inertia along y is the opposite of bd cube, which is db cube all over 3. And the centroid, or I, based on the gravity of x, is equal to bd cube all over 12, and the gravity I, gy, is equals to dv cube all over 12. Another shape is a circle with a radius r, and the diameter is always equal to twice of the radius. And the area for a circle is equal to pi r squared, or in terms of diameter, it is equal to 1/4 pi d squared, or pi over 4 d squared. And the centroid of I, gx, is also equal to IGY, which is equivalent to pi r to the 4th all over 4. In terms of diameter, it is pi d to the 4th all over 64. What about the centroid? The centroid is always at the center of the circle. Quarter circle, which means 1/4 of area of a circle. The area is 1/4 of pi r squared, and x sub c is also equal to y sub c. So x sub c and y sub c are the same value, and it is equivalent to 4r all over 3 pi. Moment of inertia along x and y are the same, which is pi r to the 4th all over 16. And igx is also equal to igy, and it is equal to 0.055 r exponent 4. Semicircle. which means 1/2 of the total area of the circle, or area is equals to 1/2 of pi r squared, where y sub c is equal to 4r over 3 pi, and I sub x is equal to I sub gy is equal to pi r to the fourth all over 8, and igx is equal to 0.11 r to the fourth. And the last is ellipse. We have the distance a and distance b along the centroid of the plane area ellipse. And the area for ellipse is always equal to pi ab. I sub gx is equal to pi ab cube all over 4, and igy is equal to pi ba cube all over 4. So interchange a and b and a. The longer distance is a, while the shorter distance is b.
Example. Determine the moment of inertia of the area with respect to its centroidal axis. So we have the shaded area with bottom base is 12 inch and top base is 6 inch, and with the height of 14 inches. First, we will locate the centroidal axis of this plane area, x sub o and y sub o, which is the axis of the centroidal, and we will find the value for y bar, and we will subdivide it into 3 parts. So this is the first part, and the second part, and the third part. This is area 1, and this is area 2, and area 3. And we will solve area 1, 2, and 3. So area 1, which is a rectangle, and the dimension is 12 inch and the height is 1 inch. So 12 inch and the height is 1 inch, and a total of 12 inch squared. Next, area 2, which is a vertical rectangle, and the base of area 2 is 1 inch and the height is 12 inch. So 1 times 12, and this is 12 inch squared. Area 3, and area 3 is the top base rectangle. So the dimension is 6 inch and the height is 1 inch. So 6 times 1, and it is equal to 6 inch squared. So the total area for the shaded area, it is area 1 plus area 2 plus area 3 equal to area 1 12 plus area 2 also 12, and area 3 is 6 inches squared. So 12 plus 12 is 24 plus 6, it is 30 inch squared, and this is the total area. And to find the centroid, the formula is y bar times area total is equal to area 1 y1 plus area 2 y2 plus area 3 y3. And to find the distance of y1, y2, and y3, y sub 1, which is based on area 1, and the centroid of area 1 is this point, and half of that of the height, which is 1 inch, is 0.5 inch. So 1/2 of 1 inch, it is equal to 0.5 inch. Y sub 2, y sub 2 is from this point of area 2, this is y sub 2. 1/2 of the height of area 2, which is 12 inch, 1/2 of 12 plus the thickness of area 1, which is 1 inch. So 1/2 of 12 is 6 plus 1, and it is equal to 7 inches. Next, y sub 3. Y sub 3 is the area 3, and half of that, and the height, or y sub 3, this is y sub 3, and y sub 3, the height is 1 inch plus 12, and 1/2 of the height of area 3, which is 1, or 1/2. So 1 inch over 2, and 1 plus 12 is 13, plus 1/2, or 13.5 inches. So we have now the values for y sub 1, y sub 2, and y sub 3. And we substitute the values to equation 1. So y bar times the area total, which is 30 inches squared, is equal to area 1, which is 12. So 12, and y sub 1 is 0.5, plus area 2 is 12, and y sub 2 is 7 inches, plus area 3, which is 6 inches squared. So 6 inches squared, and y sub 3 is 13.5. And y bar is equal to, so 12 times 0.5 is 6, plus 12 times 7 is 84, and plus 6 times 13.5, and the total is 171, and we divide by the coefficient of y bar, which is 30, and y bar is equal to 5.7 inches. 5.7 inches. Location of the center of the axis, so we can find out the values for the moment of inertia. And the formula for moment of inertia, based on I sub x, this is equal to Igx plus area d squared. So this is equation 2. And for y-axis, so I sub y is equal to Igy plus area d squared. So this is based on d along y, and this is d along x distance. And this is equation 3. So we will find first the value for Igx of the three areas, I1x, and the formula for rectangle, it is bd cubed over 12. bd cubed, and the base of area 1 is 12, and the height is 1. So the base is 12 multiplied by the height of area 1, which is 1 cube all over 12. I sub 1x is equal to 1 inch exponent 4. Next, a sub 2x. This is based on area 2. A rectangle, which is bd cubed over 12, and the base for area 2 is 1 inch, and the height is 12. So this is 1 times 12 cube all over 12, and the value is, cancel out 12, and it is 144 inch exponent 4. Moment of inertia at 3, or I3x, which is the base is 6 inches and the height is 1 inch. So bd cubed, base is 6 and the height is 1 cube all over 12, 0.5 inch to the fourth. At 2, Ix, or I sub x, is equal to Igx of area 1, I1x plus area 1 d1 squared plus I2x plus area 2 d2 squared plus I3x plus area 3 d3 squared. Get first the distance d1, d2, and d3. d1 and d1 based on the centroid along x sub o from the centroid of a sub 1 up to x sub o, and this is d1. And d1 or y bar minus half of 1 inch. So this is y bar minus 1/2 of 1 inch, and y bar, it is 5.7 minus 1/2 of 1 or 0.5. So 5.7 minus 0.5, 5.2 inches. That's d1. Next, d2. d2 based on area 2 and the centroid up to x sub o, and this is d2. And d2 y sub 2 minus y bar, and the value is d2. So this is y sub 2 minus y bar. So y sub 2 is equal to 7 inch minus y bar, which is 5.7, and d2 is 1.3 inch. And last, d3. d3 is from the centroid of area 3 up to the x sub o. From the centroid up to the x sub o axis, d3. And d3, which is the total height, is 14 less 1/2 of the height of a sub 3, which is 0.5. So therefore this is d3 is equal to 13.5 and a minus y bar. So y bar, 13.5 minus y bar, it is 5.7, and d3, it is equal to 7.8 inch, and that's d3. We substitute the values for d1, d2, and d3 in our equation. I sub 1x is equal to 1 plus area 1, which is 12, and d1 is 5.2 and squared, plus 144 plus area 2 is equal to 12, and d sub 2 is 1.3 squared, plus 0.5 plus a sub 3, 6 inches squared, then d3, 7.8 and squared. And the value for I sub x is equal to 855.3 inch exponent 4. So this is I sub x. Now we have the value for I sub x. We will now get the value for I sub y. And I sub y is equal to, at equation 3, I1y plus area 1 d1y squared plus I sub 2y plus area 2 d2y squared, and plus I sub 3y plus area 3 d3y squared. And we will check now d1y, d2y, and d3y. And based on our y sub o, which is the centroid of along y axis, centroid of area 1 is at the y sub o. Also, area of 2 or area 2, the centroid is also at y sub o, and area 3, the centroid is also at y sub o. which means the value for d1y, d2y, and d3y are all 0. So the distance is equal to 0. d1y is equal to 0, d2y is also 0, and d3y is equal to 0. So we cancel out to 0, and the remaining equation is I sub 1y plus I sub 2y plus I 3y. I sub 1y, and the area 1, which is the base now, is 1 inch and the height is 12 inch, which means BD cube over 12, or 1, which is the base, times the height, which is 12 cube, and divided by 12. So I sub 1y is equal to 144 inch exponent 4. Next, I sub 2y, and the base for area 2 along y, which is 12, and the height is 1 inch. And this will be, the base is 12 and the height is 1 inch cube all over 12, and I sub 2y is equal to 1 inch exponent 4. So 1 inch exponent 4. And last, I sub 3y, and the base for I sub 3y along y is 1 and the height is 6 inch. So BD cube over 12, and the base is 1 and the height is 6 inch cube all over 12. And the value for I sub 3y is equal to 18 inch exponent 4. So we have now the value for I sub 1y, which is 144, I sub 2y, which is 1 inch exponent 4, and I sub 3y is equal to 18. So we add up I sub 1y, which is 144, plus I sub 2y, 1, plus I sub 3y, 18, and the value 163, and it is in inch exponent 4. So 163 inch exponent 4, and this is I sub y. Moment of inertia for I sub x is 853.3 inch exponent 4, and the moment of inertia along y, or I sub y, is equal to 163 inch exponent 4. So these are the values of the moment of inertia with respect to centroidal axis. Find the moment of inertia about the indicated x-axis for the shaded area. And we have to find the moment of inertia along x-axis, which is, this is the x-axis. So we will now locate the area. We will form dotted line, form a rectangle. So this is area 1, and we will deduct the half circle and we designate as area 2. Let's find the values for area 1, which is a rectangle. The base of a rectangle is 8 inch and the height of a rectangle is 10, or 8 times 10 is equal to 80 inch squared. Area 2, which is a half circle. So the formula for a half circle is 1/2 of the area of the circle, which is 1/2 of pi r squared, and 1/2 of pi, the radius is 4 inch squared, and the area 2 is equal to 25.133 inch squared. And the formula for moment of inertia I sub x is equal to the moment of inertia of a rectangle minus the area, or the moment of inertia for the half circle. And the formula, I 1x plus area 1 d1 squared, and this is for rectangle, minus the moment of inertia of the half circle, I sub 2x plus area 2 d2 squared, and this is equation 1. I sub 1x, which is a rectangle, and the formula is bd cubed over 12, bd cubed over 12, and the base of a rectangle along x-axis is 8 inches, which is the diameter of a half circle, and d is the height, which is 10 inches. So 8 times 10 cubed all over 12. So I sub 1x is equal to 666.67 inch exponent 4. I sub 2x, which is a half circle, and the formula for half circle of moment of inertia is 0.11 r exponent 4, and the radius is 4 inches, so 0.11 times 4, which is the radius, and exponent 4, and the value for I sub 2x is equal to 28.16 inch exponent 4. And now we will find the values for the distance d1 and d2 from the x-axis up to the centroid of a rectangle and the centroid of the half circle. So d1, and the location for d1 is from x-axis up to the centroid of the rectangle. So this is the centroid, and this is d1. So d1 is equal to 1/2 of the height of the rectangle. So 1/2 of the height of the rectangle, which is 10 inches, and d1 is 5 inches. d2, which is from the centroid of the half circle up to the x-axis, and this is d sub 2. So d2, which is the height, is 10 inches. The centroid from the base of the half circle, the formula 4r over 3 pi. The height, which is 10, minus 4r over 3 pi. So 10 minus 4, and the radius is also 4 all over 3 pi, and d2 8.3 inches. So we have now the values for d1 and d2. At 1, ix or I sub x is equal to I sub 1x is 666.67, 666.67 plus area sub 1 or A1 is 80, and d sub 1 is 5, and square. So this is the moment of inertia for rectangle minus the moment of inertia for the half circle, which is I sub 2x 28.16 plus A sub 2 25.133, and D sub 2 is 8.3, and squared and close parentheses. So 666.67 plus 80 times 5 squared, this is 2666.67, minus, so 28.16 plus 25.133 times 8.3 squared, which is 1759.57, and the value is I sub x is equal to 907.1 inch exponent 4, and this is the value for I sub x based on the shaded area. And this is the answer.